This is our final year project, Mangrove classification of Indus Delta using satellite images. This project is supervised by Dr. Naeem, myself Abdul Rafi, I am the group lead, and this is my group member Akash Kumar. Problem statement is that the mangrove loss contributes a significant fraction to the coastal erosion and the global warming. That is why understanding them is very critical to meeting the UN SDG indicator 6.6.1. Indus Delta is also home to the 7th largest mangrove forest in the world. Field surveys for mapping mangroves can be very tedious, time consuming, and costly. That is why this study project is geared towards using the applications of remote sensing along with the help of machine learning to identify mangroves and map their extent. So the goal of project is to understand and classify the mangroves of Indus Delta using satellite imagery without doing the field work. What is a satellite image? A satellite image is the image of Earth collected by imaging satellites such as Landsat and Sentinel. Satellite captures the reflected light from the ground. The value of light captured is also known as reflectance value. Sentinel-2, Landsat-8 and Landsat-7 images were used in this project. Landsat images have a spatial resolution of 30 meter. Each pixel of Landsat image occupies the area of 30 meter at the ground level. So these are the bands which are captured by the Landsat at satellite image. From the visible spectrum to the near infrared and shortwave infrared spectrum, Landsat 8 also captures the thermal bands which indicate the temperature at the ground level. What is the classification? Classification is basically turning the pixel values of the satellite images into the classes. What it does at the background is that it turns the measured reflectance value into land cover classes. This project used the supervised classification method for classifying the mangroves of Indus Delta. Supervised classification workflow is as follows. We have an input image, we pre-process that image, and then we collect the training data. Based on the training data, we train the classifier, classify the image, and based on that classified image, we perform an accuracy assessment. Based on the accuracy assessment, we can tune the parameters or collect more data and then post-process the image. So our Indus Delta was the study area for this project. Input image that were used for 2021 classification was Sentinel-2 multispectral instrument, and for the 2020 classification we used USGS Landsat 8 surface reflectance tier 1 image, and for the 2010 and 2000 classification we used USGS Landsat 7 surface reflectance tier 1 image. Image pre-processing was done by cloud masking and reducing the best image by median reducer from the image collection. Features were selected for each class, which is mangrove, other and water, and were assigned a numeric value from 0 to 2. Elevation, NDVI and MNDWI masks were applied to reduce the images. The following indices or bands were also added. The first one was NDVI, and then NDMI, which is normalized difference mangrove index. MNDWI was also added as a band. GCVI, simple ratio, band ratio between shortwave infrared 1 and near infrared, and the ratio between red and shortwave infrared 1. The data was collected by visualizing each image and finding the area manually where mangroves existed for each classification. Because the images were masked, it was very easy to identify the mangroves. Some data was also collected from previous researches in the same area. Mangroves were easily identifiable in the false color composite especially. We used the random forest classifier because from the literature review, it was proven as the most efficient and accurate classifier in the mapping of mangroves. So this is the classified image of Indus Delta, which is classified into 3 classes, which are mangroves in green, other in gray, and water in blue. Accuracy assessment was performed, and we were able to achieve 97% accuracy in confusion matrix, and random accuracy was greater than 80%, which was calculated by using the stratified random points in QGIS's class accuracy plugin. After that, for improving the accuracy, we tuned the model by providing the parameters which resulted in more accuracy, and more data was added to improve the model where it was needed. Image post-processing was done by removing the noisy pixels from the image, and class masking was done and the area was calculated for the mangrove loss. So that's all for the theory. Now let's see the project working. So this is the working of our project. Basically, this is Google Earth Engine application which I have published on the Google Earth Engine platform. So as you can read this title, it indicates that using this tool we can explore the height, extent of the mangroves in the Indus Delta, and we can also view the extent in 2000, 2010 and 2020. The extent was calculated using random forest classification derived from Landsat imagery. Using the tools below, we can explore the changes in mangrove extent, mangrove canopy height, and drivers of mangrove loss. So basically, I have also imported all those classified images in this tool, uh, which can be viewed in this map here. So this is currently viewed as satellite, but for a better view, I want to switch it to the map view. So this is the map view of the map, and now let us see the 2000 classification of Indus. Before I want to show you the natural color image of Indus Delta. So this is the natural color image of Indus Delta. We can also switch it from here, this button. Now let us view the false color composite of that image. So now as you can see, these reddish pixels are basically the healthy vegetations in this area, which are most likely the mangroves, and these are the sea creeks. Now let us visualize the NDVI of the Indus Delta. So basically this is the NDVI composite of the Indus Delta, in which the greenest pixel is healthy vegetation and the whitest pixel has basically very low in NDVI. So it is basically a barren land or water area. And now let us see the modified normalized difference water index composite of the Indus Delta. So this is the modified normalized difference water index composite, in which the bluish pixel is water, while the whitish pixel is most white pixel is basically barren land which has no water, and there are some pixels which are white bluish. So these are vegetations, because vegetations reflect some bands of the water because they are wet. So these are all the composite. Now let me turn these off from the layer so that we can view the classified images. So I have imported those classified images in tagged image file format, which are geotiff images. So basically this is the 2000 level classification of mangrove forest. So these purple color areas that you see in the map are mangroves. So these are classified into the mangroves. Now let us see 2010 mangroves. Let me turn this off. So this is 2010 year of mangroves, as you can see, and now let's visualize 2020 classified mangroves. So these are the 2020 classified mangroves, and here we have a graph in which we can easily visualize that in 2000 there were 68,000 hectares of mangroves, and in 2010 70,000 hectares of mangroves were there. So basically this is a low number because of the flood. Some of the mangroves were not visible in satellite images. Actual number was greater than that, and in 2020 we have one greater than 1 lakh hectare of mangroves in Indus Delta. And with them also I have imported a public data set which is similar to all 2019. It basically gives us the basal area canopy height of the mangrove forests. So let me import it. As you can see, when I click a particular place, for example I click here, it will give me the basal area canopy height of the forest, that is 3.23 meters. And if I click it at somewhere which is not dense like this, so that will be 2.15, and like this we can easily visualize the basal area height of the mangrove forests. So this was my project in which I have classified the mangroves, and we can easily visualize and detect changes. We can visualize why the mangroves from that particular area were lost, because I have also imported the MNDWI and DVI composites along with the false color composite and the natural color composite. This was all for the project. Now let's reset it. Thank you.